Hi everyone, so in today's video we're going to look at smart materials focused on the first year content. So what you're going to need to know for your exam are a couple of things. First of all, what the smart materials actually are, what they do, and then what their real life applications, what their actual uses are. So the main ones you need to know about are thermoceramics, shape memory alloys, reactive glass, liquid crystal displays, photochromic material, thermochromic material, and quantum tunneling composites. You're also going to need to know what the difference is between a smart and a modern material. Now, some of them you may have covered at GCSE, and some of them are probably going to be a little bit more new to you. So the first one is shape memory alloys, SMAs. So the most common example is nitinol. So what this is, so typically you can see this in things like springs or glasses frames, and you have basically a thin pipe of metal, and you can distort and bend it into any sort of shape, and then what you can do is either apply something like heat or an electric current to it, and it will resort back to its original shape. Now this is also used commonly in things like dental braces. So if anyone's ever had like the train track braces, and what they can do is they can add a little bit of heat or a little bit of electrical current, and it will slowly go back to its shape, and it will set the teeth in place. It's also used if anyone's ever had pins or screws put into broken bones. So it reacts with the internal body temperature and will slowly set the bone back into the correct place. The next one is thermochromic material. So this is one you've probably covered before at GCSE if you've done it. So thermo means heat. So essentially what it is it's material that changes colour in response to a change in temperature. So most common ones you may have seen on like viral videos, you've got like things like mugs, where if you pour hot water into it, the pattern or the colour of the mug changes in reaction to the heat. It's also quite commonly used on things like frying pans, where you have like a little red dot in the middle of the frying pan, and it will change the colour when the temperature is like the perfect cooking temperature. They've also started putting them on things like canned drinks. So if you put your drink in the fridge, and the colour will change when it's supposed to be like the perfect drinking temperature. And they're also quite commonly used in things to do with feeding babies. So if you've got like spoons, so you can check that it's not going to be too hot that it's going to hurt the baby when you try and feed them. So your next one is quantum tunneling composite. Now this sounds a lot more complicated than it actually is, and this is a very A-level specific one. But essentially what you have is you have a sheet of material that almost looks like rubbery, like a sheet of rubber, and what will happen is if you just leave it, nothing happens, and if you squeeze it, it then starts to conduct electricity. Now the reason that works is on the inside of it, so if you look where the mouse is, so you've got all these atoms on the inside, all these electrons, sorry. So what will happen is you will have they'll be spaced apart, so no electrical current can go through. If you then apply pressure to it, it closes down and all the particles go closer together, which then means that the electrons can pass through a lot easier. Now this is used in things like sports clothing, where they're going to measure impact. So that's how, if people have ever watched like rugby or American football, and they can tell you how much force has hit someone. It's also used in things like boxing and MMA, where they have it in the gloves so they can tell how hard someone's being hit. And then in things like in the Olympics, where you've got fencing, so when fencing, and it will beep when they've been stabbed because it lets them know, okay, force has been applied to it. It's also potential for things like touchscreens, so you can actually press your touchscreen, and the amount of pressure you press depends on how much, like, so it will actually make a difference to it. So you can do a light press or you can do a hard press, and it will have a different effect to it. And then a fun one is always where you've got like the matte keyboard, so you put that on the floor and you like step on it, and it's like a little keyboard that you can walk across. So thermoceramics, so these are advanced ceramic materials that basically can withstand a huge amount of temperature and stay completely stable. So what will happen is, if you've got your composite, the way it's been like formed with metallic powders at a very high pressure, you can put it into an oven and it will get to huge temperatures, and you will be able to touch it because it disperses the heat very, very easily. So the benefit of that is that you can use it in things like turbine blinds in jet engines or F1 cars. And it means that if it's going red hot, it's not going to crack, it's not going to break, but also someone can work on it as well. However, the problem is they are very, very brittle, so if it gets knocked or it gets dropped, they're going to shatter. And they are very expensive because it's still a relatively new development in the past few years. So we've got photochromic material. So when it has photo in the name, typically that means it responds to UV light. So photochromic material is glass or plastic that you've got in it that will change depending on the amount of UV light that shines onto it. Now, the most common one you may have seen is some people have got sunglasses or glasses that will do that. So they go inside and it's normal, you go outside and it turns into a darker shade. In the workshop, we've got that for things like welding goggles. And then if anyone's ever done welding, so you've got your welding mask on and you can see through it the moment you start welding because of the bright light. Automatically, it goes completely dark and it protects your eyes. You've then got reactive glass. So reactive glass is glass that has got liquid crystal molecules inside of it, and they are all aligned on the inside of it, and that means that light can pass through it no problem. When the power is switched off, all of those particles on the inside of it, or those molecules, become scattered and move around everywhere, and that's what stops you from seeing through it. So this is typically being used in things like offices now, where instead of having blinds to have privacy, you can have reactive glass that sort of just shades out so no one can see through it. They're also starting to be used a lot more in more modern new build houses because it replaces the need to have blinds or curtains. Again, they are quite expensive, but they are starting to become a little bit more modern. And then you've got your liquid crystal displays. So these are now pretty much how most TVs, computer monitors are used, along with mobile devices and laptops. And what will happen is when there's no backlight going through, it's what makes your display come out really, really clear. So it allows the liquid crystals allow the light to twist and turn to get the different colors to come out onto your screen. Now there is a video link to the top. I'm going to put that into the link description so you can have a look at the actual explanation properly of it. But the idea is that's what stops different colors coming through, that then allows the different color pictures to arrive on your screen in a lot clearer way. So just to clarify, the key difference between modern, smart, and composite. So modern materials are materials that have already existed, but they've then been altered to improve their properties in some way. Smart materials are materials that react with an external input. So that could be heat, that could be light, that could be moisture, it could be anything. And then a composite is a material comprised of two or more different materials to enhance their properties. So composites, so the most common ones you'll come across are things like carbon fiber or carbon fiber reinforced polymers, glass reinforced polymers, concrete or reinforced concrete, fiber cement, and tungsten carbide. Now things like carbon fiber, really, really commonly used in things like F1 cars, racing bikes. Glass reinforced polymers are really, really common in things like luxury yachts. Concrete and reinforced concrete obviously is used in things like construction. Tungsten carbide we use a lot now. You can get like wedding rings that are really expensive out of tungsten carbide and they won't scratch. But most commonly and most likely for you to see, or we can get like cutting bits for like milling machines, routers, drill bits that are made out of tungsten carbide because they will cut through anything without breaking. And then fiber cement as well is used in the construction as well. So for those main ones, can you just write out what it comes from, what's made from, properties, and the most common uses? So pause the video now, have a chance of writing those down. Okay, and the last thing I want you to do is you've got 3 questions, 8 marks. What you'll do is pause the video, have a go at answering it, and then unpause the video for me. Okay, so that is the end of smart materials. If you've got any questions, please do send me an email. Now you'll notice that on each one of those slides there is a video link. I'm going to link those into the description of this video as well for you to have a look at in case you want to have a look at any more detail.